as we think about toxicity of substances, we also utilize these graphs that are called a dose-response curve. And the dose-response curve basically shows the effects of different dosage levels of a toxin or a drug or a chemical or substance on an organism. The dose is plotted on the x-axis, as you can see here. Dose increasing, it's in milligrams in this case. And then the effect, often it's mortality, or it could be some other effect, is plotted on the y-axis. And so here we can see some examples of dose-response curves. So let's look at this graph here in the lower left. So for this substance, this is just a generic graph. For this substance, if the dosage is between 0 and about 6 or so, there's really no response. There's no effect on the organism. As the dosage increases, what we see as the effects, often this is mortality, increase here and start to increase pretty rapidly and then eventually level off. And so what we see is that we can use the dose response curves to figure out the LD50. That's a common question that comes up. So how do you figure out LD50 based on a dose response curve? You just go and you look at the 50% mortality rate on the y-axis, follow it over to the graph, follow it down, and see what the dosage is at which 50% of the individuals die. So in this case, the LD50 for the substance is 20 milligrams per kilogram. If we look here, there's some different types of curves that we see on these dose-response curves. Sometimes there's a linear dose-response curve, which means as soon as individuals are exposed to this substance, they begin to die off, and there's a linear relationship there. Other times we see a threshold dosage. So that's like this graph on the left and this graph in the lower right, that for some dosage of this chemical or toxin, there's no effect. Organisms don't die until you reach this threshold level, and then the response starts. So there's a threshold dose here is about 6. Threshold dose here is about here. It's not numbered. But those are two different common shapes of dose response graphs that we often see.